Good afternoon, AP Psychology students. You are watching a video recording of me because at this point in time I am traveling on an away soccer game, so I couldn't be with you and I apologize for that. But hopefully this video suffices in what you needed to still understand and get for the day. So the plan for today is I'm going to be continuing on in what we just briefly introduced last time with research methods, and hopefully I wowed you with my ability to read your minds, if that worked out for me. And now today we're going to actually go a little bit through some more lecture notes regarding why it's important for psychology to be a science and how we follow the scientific method. And we're going to be learning all about this thing called operational definitions. The ultimate goal for today's lesson is once we get done with it, I'll show you really quickly here. There's going to be a Google question, and I'll talk more about this at the end. This will be like your exit ticket for the day. When I'm done with this video, you'll have an opportunity to go on to Google Classroom here and type a response to the prompt here, and that will be what you do to get credit for today's learning. All right. For now, though, I'm going to go into the notes, and that will be in Unit 1 here, Continued Research. This is the notes that I introduced to you guys last time, even though we didn't really get very far into it. Today, we're actually going to go through a handful of slides that go along with it. So just a reminder, I made it through that ESP demonstration, and we talked about how that relates to psychology as a science and some of the things that are necessary to understand. So what we're going to do today is kind of dive deeper into that idea, psychology as a science, why the scientific method and operational definitions are important. So um, first off, why does psychology need to be a science? Why isn't it just fit into the humanities? How come we keep calling it a science? It's kind of a weird thing where I'm a social studies teacher and I'm teaching it, and I'm not a science teacher, but it is technically a science. And the reason that psychology needs to be a science is to help deviate it from a philosophy. Remember, way back in our last conversation last week, we were talking about how it transitioned from a philosophy to a science. The idea behind that is that philosophy is great when you're talking about ideas, but if you want to prove something, you need to find a testable hypothesis, right? You need to collect data on it. And psychology is trying to do that to describe human behavior and thinking, is what can we try to prove about human behavior and thinking by following the scientific method. And that's also because there are certain things that might seem obvious to us, but turns out they're not. So we talked about some of these examples already, but the more people that witness an emergency, the less likely that individuals get help. That's called the bystander effect. Opposites do not always attract and last. And learning styles might seem like something that are very obvious, being an auditory learner or a visual learner, but it turns out some of those things aren't backed by the research. But how do we know any of that? We know these things because they have been studied through different experiments. And not necessarily today, but more so next class, we'll talk about different ways that psychologists will collect data through different experimentation. All right. So the scientific method, this is something you should have learned about in one of your science classes already, probably multiple times over. Sometimes there are different acronyms here, but it's the same general idea that you always start off with a problem, right? There's a question that you're trying to answer about something. And then we have a hypothesis, a belief about what might be true of the problem. And then you carry out some sort of research, experimentation, or observation, or both. And then you look at that data, and from that data, you can draw a conclusion. Did your hypothesis turn out to be true? So a hypothesis is a testable prediction. It's a belief that something will happen. So my example down here, if we were to study how being sleep deprived, how that impacts student performance, my personal hypothesis would be a lack of sleep hurts you academically. That's not a very surprising hypothesis, but I do think there's a lot of evidence to back that up, and that's my belief. That would be my hypothesis. But how could I actually measure that? What could we do to run some sort of an experiment? Well, this is where operational definitions come in. So, an operational definition is the exact way that you're going to be measuring something in a study. How are you going to be collecting data on sleep deprivation? You can't just say willy nilly, like, well, who's tired today? And then, like, jot it down. How are you doing with your grades? That's not a very good operational definition. A better way to do it, you can see this down here, is it says that sleep maybe could be measured in X hours. So you could collect data on a weekly basis about how many hours of sleep are you getting. And then maybe I could measure school performance by looking at GPA grades, or it could be something else. But as long as it's school performance related and there's an exact measurement, that's what we mean by an operational definition. And I'll give you some more examples of operational definitions in the upcoming slides, but they're very important to understand. because it helps you replicate your data. So if I were to run this experiment on saying, I want to collect info on how much hours of sleep per night a person is getting or a group of people are getting, and then I want to see what their GPA is and see how those things are correlated. If I were to run that study again and again, and maybe in different high schools, in different experiences or different times of the year, do I get back the same data? Well, I better be sure that I'm using the same measurement sticks, right? That I'm using hours of sleep to determine sleepiness, and I'm using GPA every time. Because if I compare GPA to some other operational definition, like, days showing up to school, right? That's another success sign for students. It wouldn't work if I'm comparing apples to oranges, right? So you got to make sure you have the same measurement. And that's the importance of operational definition. It's especially crucial to do it in a scientific way when it comes to measuring psychological phenomenon, because there are some things that can block our critical thinking, the assumptions we can make about life, and hoping that the results are obvious. So one of them is called hindsight bias. It's something that you're going to try to want to avoid when you're collecting your own data. You guys will have a chance to create your own experiments eventually in this class. And when psychologists are thinking about collecting data, they want to try to avoid this thing called hindsight bias. So it's otherwise known as the "I knew it all along" phenomenon. So after learning about some sort of outcome, we have a tendency in our mind to be like, "Oh, well, that makes sense. Like, now that you explain it that way, it totally makes sense that we foresee the future." When in reality, maybe we did have a different opinion before. This is why collecting data is so important, to kind of prove what we might believe or not believe, and make sure that we have a clear understanding of what's before us. There's also overconfidence. This is sometimes blocking our ability to think clearly about what the results of a psychology experiment. We tend to think we know more than we actually do. There's a lot of assumptions that we understand how the world works, right? Um, we'll learn more about this later, but there's this phenomenon in psychology where if you just know a little bit on something, you kind of think you're an expert. But actually, the more you engage in that subject, the more you realize, oh, I'm not really an expert. There's a lot of things I don't know. And then eventually you learn so much that you now become an expert again. That's called the Dunning-Kruger effect. But most of us suffer from overconfidence, right? We are overly confident, thinking we know a lot of stuff about human behavior, politics, school, whatever it might be. And then also another thing that is important to do when it comes to carrying out experiments, or why we carry out experiments as compared to just observing our world. Sometimes we like to perceive order in random events, right? Being kind of superstitious, seeing certain patterns like, oh, it's Friday the 13th. Actually, today is Tuesday the 13th, but if it was Friday the 13th, that would be something that some people would be like, oh my gosh, like watch out for those bad luck things that are going to happen to you. You got to be on guard. And then when something bad does happen, we're like, oh, those two things are connected. When in reality, does the data actually support that? And so the whole point of this slide is just to argue that it's important that we make sure we collect empirical data on things in order to verify the studies that we're looking at. Okay. I don't know if you guys have seen the movie Office Space, but this is a joke from that. If you haven't seen it, don't worry about it, because otherwise the joke won't be funny. So okay, so just I think 2 slides left here, and then you're going to have some time to reflect on some of these things. So why do operational definitions matter so much? I kind of made a big deal about this before. Again, an operational definition is the way that you are measuring something. Part of the reason operational definitions are important is because of the need for replication. So if I go out and I collect data on something, like I want to study, let's say, does having your assignment on a sheet of paper that's blue make you perform better than white, right? I have this belief that blue is a nice calming color. And because it's so calming, students will be in the right mindset, and I should just do all of my assignments on blue instead of white. Now, is that data going to work out the way that I think? I don't know. But let's say I do collect data and I run it on one of my AP psychology classes. I get back data. Turns out, awesome. They did better on this test than they did on the last test with the blue versus the white. So I'm going to say, yeah, definitely worked. Now, here's the thing. In order to verify that study, psychologists like to replicate it, which means run the same study again and again in different contexts. So maybe with a different group of students, different time of the year. That will then be able to be replicated. But if I alter the experiment in any way, I'm looking at different collection of data, like different results, or a slightly different color blue, right? then you don't have the exact same study. There's now different variables in the study because you've altered things slightly. So operational definitions help keep the experiment consistent to know exactly what you are studying, help keep it reliable, right? So that you get the same results every time. And if you don't get the same results every time, then it just shows that maybe that first time was kind of a fluke and it's not really a good empirically verifiable study. So without operational definitions, things can get rather messy. Okay. So here's an example that I like to use here. I'll get my face out of the way. I'll put myself right here. So obviously, I'm not here with you, so this will be a little bit more difficult. But just to show you how not having clear operational definitions can be a little bit messy, I want you to look at these pictures of people. There are 6 of them up here, 7 with myself, but 6 right now. And I want you to decide, don't say it out loud. I want you to decide how many of them do you think are smiling? So you can analyze their faces, count it in your head. You think none of them are smiling. 1, 2, 3, 4, 5, or 6. And now what I would normally do in class, and I'll just like do this and you can participate and follow along, I suppose, is raise your hand if you think none of them are smiling. Raise your hand if you think only 1 is smiling. 2, 3 people smiling. 4, 5, all 6. Okay, my guesses based on when I've done this in the past is oftentimes we either get a lot of people that say like 2 of them are smiling. And usually when I ask which 2 is it, it tends to be the one in the upper corners, right? And I ask, okay, well, why is that? Students will often say, well, they're showing their teeth. And that is an example of their operational definition of smiling. To smile means you have to like be showing your teeth. But that's not always the case for everybody, right? Some people might have said the guy down here is smiling, right in the middle, because maybe it's more about the curvature of the lips going up, and that's what you're looking for, or something in the eyes. Maybe you're looking at the eyes. We'll talk more about this when we study emotion in this class. There's this thing called crinkle eyes, which when your eyes on the sides kind of get crinkly when you smile really big. That's something you could look for as like a true smile. Or maybe you thought all of them were smiling because they all look slightly happier than average. I don't know. And the point is, if I were to be running an experiment, let's say hypothetically, that I want to know whether or not certain types of music make people smile. So I have them sit and listen to music, and I just say, show me on your face whatever emotion you feel about this music. And if I was collecting this data and you were collecting this data and we had another person collecting this data and we were doing it in different rooms, if we had different beliefs about what a smile actually constitutes, whether they have to show their teeth or whether they can just raise their lips, that's going to throw off our data. So before we run the experiment, we got to make sure we have an exact operational definition to understand how I am measuring what I am measuring. So that's kind of the point that I'm trying to drive home here. All right. So here are some other examples of operational definitions and applying the scientific method. So again, if I was in class with you right now, we would do these kind of more interactive, but I will just kind of pause for effect and then give you the answer. So what might be an appropriate operational definition for each of the following? Number 1, a school wants to offer scholarship money to its students to its high student performance students. So how might we measure student performance if I'm comparing one student to another? Probably one of the easiest way to do it is by looking at GPA. Or maybe there's another metric like you guys are in an AP class. You know that it might be more challenging to take a set of classes that are almost all AP classes and still maintain a high GPA. So perhaps it's not just GPA. Maybe the first thing you look at is, well, which of our students are taking lots of AP courses? That is what we should measure when we say student performance, the number of AP courses taken. Or maybe it's attendance, showing up every day. It's pretty rare when you find people that have perfect attendance all year. It does happen, but that would be a form of performance too, that they're able to come every day and pay attention and focus. Obviously, there's some things we can't control, but maybe that's what you want to use to measure student performance. The key is, though, you have to agree that you're using the same measurement across the board when you're collecting the data. All right. Number 2, a doctor wants to know if a medicine helps with chronic pain symptoms. How could we measure helping with pain? Well, one way you could maybe do it is some sort of like self-reported survey. So on a scale of 1 to 10, maybe you've seen charts like this in doctors' rooms. Like they have pictures of like, how are you feeling today? And there's like a sad face, and then there's like a happy face, an average face. Maybe you could do something like that on a scale of 1 to 10. How do you feel? So what you would need to do then is collect data at the beginning. how much pain are you in on a scale of 1 to 10? What number do you feel? And then you would basically run the study where some individuals would take this pain medication over a period of time. And later in the study, you would collect data back and say again, now where's your pain level at? And then you would look at all the data and see whether or not your hypothesis or your belief about a medicine helping does or doesn't help based on if the results change. Third one, last one here. A psychologist wants to know if listening to music increases a person's level of happiness. How might we measure happiness? Again, I would use something similar to what I did on the last one, probably some sort of survey that just says rate your level of happiness. And I would want to collect that data before they listen to music. I'd want to collect that data after they listen to music and see whether or not there's measurable difference there. Okay. So the operational definition for each of those things, student performance, we're going to say is GPA. Helping with pain, it's a survey, it's a scale. Level of happiness, again, some sort of scale or survey. All of those things are measurable, right, on a number system in a way. And it doesn't necessarily always have to be a number. Like obviously I go back. The smile thing is not necessarily an exact number of looking at when they're smiling or not, but it has to be something that you can concretely agree is measurable. Okay. Okay, so here's what we're gonna wrap up with here, and we'll probably be wrapped up a little bit early for you guys, but doing this on video means I move through things faster. So you're gonna log into Google Classroom if you're not already there, and you're gonna be responding to this Google question, thinking through your own psychological research question and how you would apply the scientific method and operational definitions. So I'll show you here what this is. In Unit 1, there is this question that will be posted by the time you see this. It says, reflect on today's learning. And it says, reflect on today's learning by coming up with a hypothetical psychology research question study and answering the questions that follow. So number 1, what is your problem/question you are researching? So you can literally pick anything as long as you can study it in a scientific way. So if you want to look at something related to sleep, related to music, related to school performance, related to sports, it doesn't really matter. I'll show you this website, I guess, right now. So I did link this website here. If you're really struggling with coming up with your own idea of what could be a studied idea in psychology, a research study, this website has a bunch of different experiment ideas. I already talked about music. Does listen to music increase the heart rate? Are men or women better at recognizing emotions? What rate do students conform at when there's something for them to conform to? And there's other ones here about the effects of sleep on memory, social media and mental health. Does spending a certain amount of time on social media hurt people's mental health? It doesn't really matter what you pick. What I want you to go through here is thinking about, now that I have my topic, right, which is basically what number 1 is, it's the question, it's the topic. What would your hypothesis be? So what's your prediction about whatever the question might be? And then number 3, what might an experiment look like? So how might you go about collecting that data? Would you put people into different groups that some are getting the experimental design and some are not? They're your control group. We haven't really talked about how to run an experiment yet, but just think through how might you go about collecting that data. When you are collecting that data, what is your operational definition? How are you exactly measuring whatever results you're looking for? Okay. And then number 5, if you collect back that data, if you predicted something, your hypothesis, what would that data have to show for you to be correct? All right. And then I just said, if you're struggling to come up with the idea, you can go to this website. Okay. So if you haven't done so already, you're just going to log into Google Classroom, find this Google question, post in Unit 1, type a response to 1, 2, 3, 4, 5. You could do this with a partner if you wanted to talk through an idea, and you guys can use the same one. That's okay. Try not to make it a large group, at most like maybe a partnership, but I really want this to be more so probably your own individual reflection, at most 2 people. So reflect on that, post a response. Once you do that, we are done for today. Next class, we will continue on in the notes and be learning about different research studies and how psychologists go about collecting data. So hope you guys have a good rest of your day today, and I will see you guys tomorrow. Thanks.